Well, good evening, everybody. I will be discussing chapter three for today's session. So it's about perpetual evolution. So it's rethinking the way digital transformations are managed by Oliver Bozert and Stefan Feldman. So I'd like to start the presentation with this. So this was actually written also in the chapter. So, why are some internet retailers are able to make crucial changes to their e-commerce website in hours, while it takes brick and mortar retailers 3 months or more to do the same? Well, because they are not required to connect their new digital systems to aging technologies in today's digital. Because in today's digital native companies, they can easily build greenfield digital business processes in online marketing, sales, distribution, and other areas. So this is why they are thriving in this era of digitalization or product servitization and dramatically reduce software release cycles, especially since these three trends thwart incumbents. So as we all know, there are companies that are still stuck on how they do business before, simply because it worked for them, and they still think that it will still work today. The thing is, it things have changed already. Technology and also the needs of everyone kept on, evolving. So in order for us to compete with the best digital native companies, traditional organizations need to adopt, a different approach to enterprise architecture, as we refer to it as perpetual evolution, because it allows them to continually upgrade their digital business processes and the included technologies. So before we actually dive into the chapter, I'd just like to introduce some of the core concepts that are used or mentioned in this case study. So what's the difference between microservices and traditional service-oriented architecture? So technically, the service-oriented architecture is built on a heavyweight integration pattern. So often an enterprise service bus that includes business logic. So while for microservices, it connects to other services using a thin integration layer that contains no business logic. So each paradigm has its own business and IT operating model. So this enables business logic between releases. This is crucial if the waterfall model is used and releases are spaced. So code can be modified directly without configuration under an agile paradigm. So to put it simply, service-oriented architecture has an enterprise scope, while the microservices architecture has an application scope. So many of the core principles of each approach become incompatible when you or when we neglect the difference. So for enterprise architecture, a framework consisting of six core elements has been developed by McKinsey around 15 years ago. And it's actually a reliable way for us to structure and communicate the complexity of architecture in large corporation. So these are the six elements of this framework that are introduced, right? So we have business operations, business capabilities, business applications, IT integration platform, infrastructure services, and information and communication technology. So a good way to understand the evolution of enterprise architecture is to consider how firms have traditionally regarded the six fundamental parts of enterprise architecture. So how would these elements differ in a perpetual evolution model? So we discussed that in detail in the following slides. So for business operations, it is actually designed with an outward view, right? So priorities have changed, as I've said earlier, that well, the customer used to be an element in a product or company-centered process. Today, the products and services are an element of a customer journey. But this does not imply, however, that the inward-looking perspective of businesses has become irrelevant, because accounting or order management and procurement and etc. are just a few examples of the types of transactional systems that companies need to reserve. They also have to make certain that the business processes and technologies used will remain effective. So if you can see on this illustration is that before, if you can see that on the left hand side, before we used to have like a product or service centered processes, but now it's more on a customer centric journeys, right? And when it comes to business capabilities, we heavily rely on one operating model before, but today we use multiple operating models. And with business applications, we heavily emphasize on interdependency. But today, we're starting to emphasize on decoupling the applications. And with the integration platform, we use heavyweight bus, but now we're starting to understand that it's easier for us to just use the lightweight connections. So when it comes to infrastructure services, software development are usually managed centrally. But today, software developers and IT operations jointly build new products and features. So hence DevOps. And that's the information and communication technology. It's before it was actually managed as a precious asset, but now it is managed as a commodity, right? So with this six fundamental changes in the stack, companies must move their enterprise architecture to one that supports perpetual evolution of their business and IT. So that will enable them to loosen up their asset base of business and system capability, so they can change out parts quickly, add new parts in no time, and replace other parts with the latest and greatest functionality. So certainly such service-oriented architectures are complex and therefore must be carefully supported by architecture management, especially for big data applications. So with business capabilities, so it says here that it's the foundation of digital competition. So in order for us to compete in a rapidly changing digital world, existing businesses must first adopt a digital model. So to implement a perpetual evolution architecture, we must be able to continuously develop our digital business skills and add new capabilities as needed. So it involves categorizing systems into two types, digital business front end systems and back end transactions applications. So this digital business characteristics enable organization to compete online. So, as an example, we consider like a retail chain that sells a growing proportion of its products through its website. So the company cannot take months to enhance its product recommendation engine when a digital born competitor can do that in days or weeks. So, for example, what kind of core system the retailer has. Its new or enhanced product recommendation approach should be able to be implemented and changed easily. So these digital business capabilities become the basis on which to compete in an online world. So after moving to a capability-based model in the first two levels of business operations and business capabilities, enterprise architects need to integrate a highly modular software skeleton in the four levels below them. So next thing that we'll be discussing is the business applications. So when it comes to business applications, so we try to shift from tightly coupled software to independent services. Human resource management. Adopting a perpetual evolution architecture will allow you to upgrade them in modules rather than having to go through the entire process of creating a new version. This can be achieved in three steps. So it's the first one will be platform services in one release container. The second is service-oriented architecture or microservices for the functional part. And of course, it's through modularity of the underlying platform. And next, of course, would be the IT integration platform for lightweight connections or integrations. So traditionally, firms with IT integration platforms included a single heavyweight enterprise service bus. So this configuration can hinder real-time digital business operations. So the connection layer can cause a bottleneck when all service calls must transit through the heavyweight bus. So organizations may struggle to deliver faster page loading times to website users. So I mean, with those delays, it costs billions of dollars in revenue. So this concept relies on lightweight connections to improve transmission performance and reduce latency. So the time it takes to deliver web pages to online clients who want fast responses, payment and promotion management systems, for example, can be disconnected from one another. So allowing changes to be made to the platform as a whole at a slower pace. Companies can easily upgrade fundamental applications within CRM, ERP, and all the other um, systems that they're using module by module or service by service instead of replacing entire systems. Application migration may be done faster with less risk of a downtime or system issues. So with infrastructure services, the concept of DevOps or grouping together of IT professionals previously separated into the functions of software development and IT operations, but it has firmly taken hold in many companies. So it has adopted the DevOps approach, which combines IT specialists from software development and IT operations. So it is essential to quickly test and deploy new digital business capabilities. With DevOps, firms can improve business capabilities in hours or days rather than weeks or months. But however, it requires that firms embed its team members in those tasked with enhancing and creating new digital business capabilities. So to put it in another way, each business capability has its own team, which comprises members from systems development as well as operational departments. And lastly, with information and communications technology, the services that are renting from public cloud vendors turn into a more affordable resource for companies of many sizes. So renting technology from public cloud suppliers makes it accessible to businesses of all sizes. So this means that expensive IT infrastructure that's built over years is no longer a competitive obstacle. Startups can enter the game rapidly. For example, like Netflix through Amazon Web Services and other digital native enterprises have. Prior investments in information and communications technologies are no longer competitive advantages or impediments. This basic stack changes on why our firms must evolve their enterprise architecture to accommodate business and IT evolution because it will allow them to swiftly swap out components, add new ones, and replace old ones with the newest functionality. So clearly, complicated service-oriented architectures require rigorous architectural management, especially for um, big applications. But first, how can we establish um, a perpetual evolution architecture? So, in helping companies across industries and regions adopt our perpetual evolution architecture, we have found they have found five moves to be more critical. So first, of course, we have to free up development teams from unnecessary dependencies. So decoupling is not a new idea in technology. So previously, it was only possible with extreme difficulty and cost. To keep the client experience competitive, all dependency must be eliminated. So to accomplish, an architecture must reduce stack level dependencies. Consider a car manufacturer that allows consumer to upgrade navigation, infotainment, and other systems online. But to sell new services a la carte, such as a navigation tool or infotainment function, automakers must develop systems that allow for independent capabilities. So marketers of new digital capabilities to specific consumers need to eliminate such dependence. A manufacturer may elect to offer young parents a new service that tracks their vehicle speed and location. But this small but profitable market niche will take a long time to develop if the entire navigation system must be written. And next, of course, we have to be consistent. We have to focus on change across all areas of the enterprise architectures. So dependencies aren't only a coding issue. There are dependencies in data, infrastructure, and decision making. The latter refers to who must approve the testing of new capabilities, the development team or senior management. So if senior management must approve capabilities before they can be solved, this will take a long time. So this kind of dependencies across all six aspects of a new piece of software have slowed down companies for years. So such dependencies are a feature, in effect, of earlier approaches to enterprise architecture. They are what forced the technology changes to be made only periodically. And we also have to regard the platform as one that will continuously change. Now, companies can isolate fast moving portions of infrastructure from slower moving components, which are the technical platforms, by separating the two. However, they must constantly enhance their platforms. You know, companies must also be able to upgrade platforms on a regular basis. You know, advancements can increase performance. To capitalize on them, a platform must be modular. It also has to be reusable because businesses can only swiftly adopt upgrades or new capabilities if the platform's components are described as capabilities. We also have to set boundaries in technology and not just on paper. We have to break down silos. You know, IT architects have often been stereotyped as people drawing funny boxes and charts, because software developers, for their part, have been viewed as the people who write the code for the modules that those funny boxes represent. So, unfortunately, this division of labor has all too often led to both groups operating in their own worlds rather than working closely together. So, enterprise architects are essential for digitally competitive companies, but they can no longer keep a distance from developers. Businesses should engage closely with developers to ensure that everlasting evolution is built into software architecture and not just code. So a team that's focused on a business capability or a set of related competencies needs architects. So some of the folks that they'll be dealing with are product managers, developers, testers, legal help, and others. So we also have to make sure that capability teams have freedom by strict separation from first from the platform. Maintaining freedom within capability teams, improvements to a company's technological platform should not influence groups working on specific business capabilities. Because with every organization, it has a platform, and increasingly other sections structured by business scales like web or microservices. They must clearly delineate these two elements of the asset base to move to a perpetual evolution architecture. This is also followed by stringent oversight and other governance mechanisms. So with this five moves with enterprise architecture, there are also implications for architecture teams. So we have enterprise architecture. There's still a need for high level architecture that connects business and IT. Digital platform architecture. Well, each feature team should own their space. They all have to rely on a common technology standard. Solution architecture, the capabilities have to be transferred to the team so that they have the full decision power within the boundaries of the platform architecture. So, with changes in our enterprise architecture, it is still necessary to transform company strategy into a target landscape and technical requirements. The enterprise architecture team must must do this, but there are some major alterations that a top-down approach is taking over architecture decisions. When technology becomes a differentiator, it becomes part of the business model. Thus, selecting the best data management or integration technology should engage the entire management team. But first, to communicate and articulate these changes, the architecture team must also demonstrate the ROI of the design decisions and their impact on the business model. So instead of standard boxes and lines, communication must focus on ROI and monetary benefits. So with enterprise architecture, it must change faster. A 10-year objective picture is obsolete due to the rapid adoption of new platforms, business strategies, and technologies. So with the organization's enterprise architecture, it must also be more connected with feature and platform teams. However, senior hands-on architects, the teams may book for support must be coached, and a self-service drill down portal that links IT architecture components to teams must be also given. And when it comes to changes for the digital platform architecture, the companies must create a digital platform for individual feature to collaborate successfully. It must be guided and sustained, but not necessarily by the architecture team. In certain aspects, managing this platform differs from traditional architecture. Like, for example, the architecture must have like digital platform design, but allow maximum user freedom. Freedom is commonly misunderstood as the freedom to change platforms, but it actually to try out new cloud providers in collect tools and technology, so you end up with an inefficient setup. Using this strategy, one company ended up with software in three different cloud environments with no means to collaborate across them. So, if a corporation uses Cloud Platform X, teams should not use Cloud Platform Y just for fun. And on the other hand, digital native organizations are often stringent when it comes to handling the digital platform itself, but not when it comes to regulating feature development. This ensures flexibility and cost effectiveness when no single team can create a competitive edge. So with platform rules, it should be carved in code in technology, not long rule set. Having each team running its own cloud environment enforces service communication. So you have to determine how software assets are linked to the teams through HR systems and collaboration platforms. It is also critical for a digital platform's success. Some corporations misunderstand that this concept allows feature teams to create their own platform. So, for example, one organization discovered over 50 separate vision control system, each with its own access rights. So this certainly hinders internal collaboration and best practice sharing. So with the changes for the solution architecture, when a company goes digital, the architectural team is generally involved in solution architecture. Companies generally accept it as best practice due to the absence of a central architecture team and in the solution architecture process. So the organization's current systems are therefore undervalued due to maturity and time. So, with most digital native teams have encountered similar challenges previously, previous experiences have taught them what to do and what not to do. Unlike these teams, incumbents starting on their first digital project must avoid creating point to point interfaces in the absence of a central architecture architectural function. So, to end this presentation, as a summary, in order for us to keep up with the technology, to stay competitive in a world in which providing great customer experience has become paramount, companies in nearly every industry must continually innovate digital products and services, as well as the business processes that support those products and services. Company must constantly reinvent digital products as well as the business processes that underpin them in order to remain competitive in nearly every industry. Their enterprise architecture management methods um, must be really effective, and they may become more flexible by making adjustments. So, to compete with the digital natives, existing businesses must think differently. So we learn about a new enterprise architecture called Perpetual Evolution that allows companies to rapidly update features, so we can add new components and adopt the latest technology. And this chapter explained how this enterprise architecture works. So we understood what was needed to move away from the old ways, and embrace the new, right? So we can gain greater agility if they abandon, on the enterprise architecture that we've used to, in terms of management practices of the past, and adopt a new approach that enables perpetual evolution. Changing out elements of enterprise architecture quickly, adding new parts in no time, and incorporating the latest and greatest functionalities. Because we understand that a lot of the way, as I've mentioned, um, in the first part of the presentation, that a lot of the way that leaders still work today is that they get still trapped in a very linear mindset. They still believe that the things that made them successful yesterday are the things that will still continue to make them um, successful today, and I think in the future. But with perpetual evolution, I think we just have to really keep up with the technologies on how the things are changing, and most especially with how the customer. I mean, what are the needs of the customers, or what are actually the demands of the users? So yeah, well, that's about it for chapter 3. Thank you so much for listening.